Hey everybody, Miss Cook here, trying to give you a quick lesson about graphs, okay? So graphs are one of the best, most useful tools in both science and math for communicating and organizing data. So the actual definition of a graph is a tool to organize data and communicate results, okay? So this is our definition of a graph, and today we're going to be comparing and contrasting two types of graphs. The first type of graph is going to be your bar graph. All right, so bar graphs have two purposes. The first purpose of a bar graph is to represent data collected from groups. The second purpose of a bar graph is to show a change of one or more groups. All right, bar graphs are awesome, but they're only good for certain kinds of data, specifically focusing on groups. All right, our other kind of graph is going to be a line graph. So over here we have line graphs, and those also have two main purposes and a way that we use them. The first main purpose is to show change of data over time. All right, that can be months, it can be years, it can be thousands of years, it can also be milliseconds. So any measurement of time. And then it's plotted with dots and it's connected with a line. So today, again, we're talking about the difference between a line graph and a bar graph. Over here, we have two different kinds of graphs, and you're probably wondering, where in the world did this cook come up with these graphs? So the first thing to notice about both graphs, though, is three things, really, that they have in common. The first thing both graphs have in common is a y-axis. The y-axis is the vertical side of both graphs, all right? And that's usually going to be your dependent variable, which is how you measure the change. Okay, so your y-axis again is vertical, and both graphs have one. And the second thing that the graphs both have in common is your x-axis. Your x-axis is your horizontal line, okay? And your x-axis is usually your independent variable, all right? So on our bar graph, we have labeled our y-axis as our seed quantity. Now, seed quantity means that is the number of seeds that last year's science classes used in their Koa Seed scarification. And I got that quantity of seeds from this table. A table is your most basic form to collect information, and this table shows a type of scarification and then the quantity of Koa seeds in 2017. There were two different ways that the seeds were scarified in 2017. They were scarified using nail clippers, which had 27 seeds scarified, and they were scarified using sandpaper, which had 18 seeds scarified. Using the data from this table, I plotted it onto this bar graph, where in blue I have labeled nail clippers, and since I know there were 27, I filled in my bar up to the number 27 on my graph. For the sandpaper, I used red, and I know that there were 18 seeds scarified, and I filled in my graph up to the number 18. And this shows the data collected from groups. And my groups being represented here are types of scarification. So, keeping that in mind, I'm going to put my table right down here so I can refer to it if I need to. I've got everything labeled, right? Type of scarification on my x-axis, and then I've got seed quantity on my y-axis. So now I'm going to move over to my line graph, and I'm going to look at the table that I used to gather this data. So, I have on my y-axis growth in centimeters, all right? And then here I have nail clippers, growth in centimeters, and sandpaper, growth in centimeters. I got all of these numbers from taking the mean or the average of growth from all of my classes last year. So I had 5 classes last year. I took all of their growth and I averaged it out. If you're not sure what that is, just ask one of us and we'll explain it to you. And then I plotted it using dots here on my graph, and then I connected those dots with a line so that I can see in blue the nail clippers grew at a much faster rate than the red sandpaper. All right? Now, when I look at this data, now that I have it all plotted, I can come up with a title because I need my title to be very, very, very specific. So, for my title for my bar graph, I'm going to say Koa scarification methods . 2017. because this is last year's data that I'm graphing, so I want to be very specific. And for my line graph, I only have 1 week's worth of growth measured. So I'm going to say week 1, growth, Koa Seed growth 2017. Because I want my title to reflect the data that it's showing, and I want it to be very specific. All right, now that I have my line graph showing a change of data over time, my time being 1 week, and I have my bar graph showing my groups of scarification, now I can talk a little bit more about the data itself. And a few things I want to go over is beyond the mean, I want us to talk about the mode, and I want us to talk about, oh, hold on, the median, and I want us to talk about the range. All right, the mode is the most repeated number. The median is going to be the middle number, so the number that's just smack in the middle of all the other numbers. And the range is going to be the lowest to the highest number. All right, and I'm using the hashtag because that actually symbolizes number. So when I look at my data here, and I'm going to put this table up here so we can refer to it, I think it's really important that we note that the mode, or the most repeated number, looking at the sandpaper, there are 2 modes, and one is 0, and the other one is 0.1, because you can have 2 modes. Those are both repeated and they tie. Now, the nail clipper data does not have a mode. There are no numbers repeated, so we're not going to add that up there. For the median, which is the middle number, we're just going to count backwards, and we're going to look for it. So if we start at week 1 and week 7 and we count back, right, we're going to go 1, 2, 3, 4. Our median number is going to be 0.1. And if we do that for the nail clippers, right, we just count back from the beginning and from the end, 1, 2, 3, 4. Our median for this one is going to be 0.5. All right. Then we're going to get into the range, all right? And the range for both of these is going to be different. For the nail clipper growth, the range is going to be 0 all the way to 1, all right? And that is in centimeters. And then the sandpaper growth, our range is going to be 0 to 0.3, all right? And it's important that we look at the range of each of these columns so that we can have accurate data. And again, it is reflected in our chart. So, big difference between bar graphs collected from groups. Line graphs are showing growth over time. One more thing I want you to really acknowledge about a line graph is going to be what we call direct relationship and indirect relationship. So for direct relationship, you are going to have your graph, and your line is going to go up like this. What that means is that x-axis goes up, and your y-axis goes up. Now, the opposite of direct relationship is indirect relationship. And for indirect relationship, can you guys guess it? You're going to have the same graph, but what you're going to have here is you're going to have your x-axis going up, but your y-axis goes down. All right? So, x goes up, y goes down. So when we look at these bar graphs here, does the nail clipper data show direct or indirect relationship between the time that the Koa Seed has to grow in days and its growth? Yes. direct relationship. Now, if it had gotten smaller, it would have an indirect relationship. So, looking at line graphs, we've got direct and indirect relationships. They both have X and Y axes and titles, but they show very different things. And it's up to you guys to look at your data and decide which which graph is going to work best for the data that you collect in your tables from your experiments. I hope that this has been a little bit helpful. I will see you guys tomorrow, and I hope you have a wonderful day.